Good day and hi everyone, we are Group 1 from Tutorial 2. Our group members consist of Izzat, Nur Alisa, Izaifa, Veronica and Hannah. Today we are going to present our chemistry PBL on the element that we have chosen, silicon. So before we discuss the properties of silicon, let me first introduce to you about the background of silicon. This element is discovered by John Berzelius in 1824 when strips of potassium in silica container being heated and washing away of the residual byproducts. Silicon is the second most abundant element found in the Earth's crust, which occupies 27.7%. It can be found mostly in the form of silicon dioxide or silicate in sands, clays, and soils. Now let's talk about the physical and chemical properties of silicon. For the physical properties of silicon, it has an atomic number of 14 and it is located in group 14 in the periodic table. The relative atomic mass is 28.085 and the density of this element is 2.3296 gram per cm cube. The melting point of silicon is 1410 degrees Celsius, whereas the boiling point of silicon is 3265 degrees Celsius. It is hard, dark grey solid, has metallic shine luster. It exists in two forms, which are brown amorphous form and dark crystalline structure in room temperature. It is a type of semi-metal or metalloid and it has a diamond cubic structure. The lower right corner picture is the image of silicon. Next, we continue with the chemical properties of silicon. Silicon is an electropositive metal. It is a covalent compound which forms 4 covalent bonds with 4 electrons. It acts as a semiconductor. It does not conduct electricity in room temperature, but able to conduct electricity when heated. Silicon has 4 isotopes, which are silicon-28, silicon-29, silicon-30, and silicon-32.
Okay, hello guys. Today I will present to you the bond that can be formed by silicon. The silicon or Si is tetravalent in nature, just like carbon. That means it can easily share all 4 of its valence electrons to form covalent bonds with other atoms or molecules. So, in order to be stable, silicon or Si needs to form 4 covalent bonds. Like carbon, it can form covalent bonds with hydrocarbon. The simplest silane that we can think of here is SiH4. This is the example of the image of bond between silicon and germanium. The electron configuration of silicon ion is 1s2, 2s2, 2p6, 3s2, 3p2, or Ne, 3s2, and 3p2. Okay, that's all. Thank you.
Moving on to the structure of silicon element. These are the molecular geometries for 2 silicon compounds, which is silicon dioxide and silicon tetrachloride. Next, this is the Lewis structure for the silicon element. Silicon crystallizes in a giant covalent structure, which is the diamond cubic crystal structure, in a repeating pattern of 8 atoms under standard condition. There are a total of 8 silicon atoms per unit cell. The silicon element is very heat resistant because it has low thermal conductivity. Silicon transfer heat at a slower rate compared to other materials, leading to excellent heat resistance. Atomic spectra is defined as the spectrum of electromagnetic radiation emitted or absorbed by electron during transition between different energy levels within an atom. This is the atomic spectra of silicon element.
And I'm here today to present about the hybrid orbital for silicon. The currently accepted theory of the atomic shell is the so-called atomic orbital model, based on mathematical functions describing the wave-like behavior or of either one electron or a pair of electrons in an atom's orbital can be calculated. Those orbitals represent a space the electron can be located in with a given probability. As you can see on the slide, it shows orbital hybridization of 3s and 3p, and it shows 4 uniform hybrid orbitals are formed out of the ball sockets shaped 3s orbital and the drop shaped 3p orbital. So next, we're moving on to orbital hybridization. On figure 2, figure 2 shows Z, Y, and X. 3D drawing of hybrid orbitals. The 4 hybrid orbitals are arranged in such a way that the distance between the orbitals is maximized. The resulting angle between the gray-colored, larger drops of the hybrid orbital is 109.45 degrees.
As for the conclusion, silicon is a hard element because it has a high melting and boiling point. So next, it can conduct electricity in only a certain condition. Other than that, it has 4 isotopes in total. It also can act as a semiconductor and has a significant types of bonding like carbon element. So, the hybrid of orbital of silicon can be defined through the ball and stick model, crystal structure of silicon, as well as the space filling model.